Section A, quadratic equations. In this section, we're going to review our methods of solving quadratic equations that we've learned in previous years. So to solve a quadratic equation, we need to use one of the following methods. First method is factorization, which is the null factor law. That is, once you get the two factors, you set each factor equals 0. Second, complete the square. Third, quadratic formula. And finally, using technology or a calculator to solve quadratic equations. Let's look at how to solve equations by factorization. Step 1. If necessary, we need to rearrange equations so that one side is equal to 0. So we have to have equal to 0. Then we need to fully factor the side that's not equal to 0 using our factorization rules. Then we're going to use the null factor law and set each factor equal to 0. And finally, we're going to solve each of these individual factors using our linear equation rules. So let's look at a few examples. Now, first example, we have 6x squared is equal to 11x plus 10. So we need to get this set equal to 0. So I get 6x squared minus 11x minus 10 equals 0. Now I want to look at factoring. So I'm going to use any method I want. I'm going to choose to use the x method that we learned last year. So I'm going to look to factors of 60 that subtract to equal 11. And then I'm going to factor each of these, simplify down. Then I got to divide by 6 and simplify it down. So I end up with 2x minus 5 times 3x plus 2 is equal to 0. Using the null factor law, I'm going to set each of these factors equal to 0. First linear equation, I'm going to add 5 to each side and then divide by 2. And then the second one, I'm going to subtract 2 from each side and divide by 3. My two solutions to this quadratic equation is 5/2 and negative 2/3. Example 2, 4x squared plus 1 is equal to 4x. We get the equal to 0 by subtracting 4x from each side. Now this time I notice my first term and my last term are perfect squares. So I'm going to check and see if I have a perfect squared trinomial. Take the square root of the first term, then the square root of the second term. Take those together, multiply those together, and times by 2. If I get the middle term, I have a perfect squared trinomial. And yes, I get 4x. So then I take so my factor is the square root of the first term minus, since my middle term is negative, the square root of the second term, quantity squared. Equation, I end up with x is equal to 1/2. This is a repeated root. That means the vertex is also at 1/2. Example, when I first look at it, it does not look like a quadratic. But you notice I have some fractions here. So to simplify this down, I'm going to do my least common denominator. So I'm going to multiply each side of the equation by my least common denominator. When I multiply that out, I end up with 3x squared minus 4 is equal to negative x. So now you can see this is a quadratic equation. We just had to do some multiplication first to get rid of the fractions. Rewrite this so I get it equal to 0. Then I can solve it in any method I want of factoring. I'm going to choose to use the x method. End up with my two factors as 3x plus 4 and my second factor as x minus 1. That's equal to 0. Using the null factor rule, set each of those factors equal to 0 and solve. I found out my two solutions, or my two x-intercepts for this equation, are x is equal to negative 4/3 or x is equal to positive 1. In example 4, it looks like it had already been factored, but there's a problem. It has not been factored because it's equal to negative 6 and not equal to 0. So when it looks like this, I have to use my full method and multiply these two factors back together, then set it equal to 0 and combining like terms. Now I have to factor this one, but I have a problem. Remember, I can't have a negative for my a term. So I'm going to factor out my negative. Then divide each side by negative 1. And 0 divided by negative 1 is still 0. So I have x squared plus x minus 12 is equal to 0. I can quickly factor this to x plus 4 times x minus 3 equal to 0. Set each of the factors equal to 0 and solve using the null factor law. And I get x equals negative 4 or x equals 3. Next, we're going to look at our second way of solving quadratic equation, and that's by the process called completing the square. I'm going to do this through examples. So let's look at example number 5. We have x plus 2 quantity squared is equal to 7. So this is already in completed the square form. So all we have to do is get the x by itself by taking the square root of each side, subtracting the 2, and then simplifying the radical if possible. This one does not simplify down. So our answer is x is equal to negative 2 plus or minus square root of 7. Now notice that in this example we have a perfect squared equal to negative. So this means there's no real solution. But there is a complex solution. To find the complex solution, we solve it just like our previous example. But remember, if you have a negative under the square root, the negative comes out and becomes an I. So our answer to this one is x is equal to 1 plus or minus I the square root of 5. Since the equation has no real solutions, graphically, this equation has no x-intercepts. So let's do example 7. 7, we're going to have to rewrite this equation into complete the square form. So first thing you have to do is get the x terms on the side by itself. So I'm going to subtract 1 from each side. Then I'm going to do what's set up blanks. I need to add something to this left-hand side of the equation, but if I add to the left-hand side, I got to add something to the right-hand side so that when I add these, I want to have some perfect square term, something that's going to be x, and I'm going to do plus this time since my second term is plus. Now to figure out what this is, I take that b term, divide by 2, then square that answer. 4 to the left-hand side, I got to add 4 to the right-hand side because I have to keep the equation balanced. Combining the right-hand side, we get it just like our example 7 and 6. So we're going to solve this equation by square rooting each side, subtracting the 2. So x is equal to negative 2 plus or minus square root of 3. And that's our first example of complete the square. So let's do one more example of complete the square. This time we got 3x squared plus 12x plus 5 equals 0. So again, get the x squared terms on the side by itself. So I'm going to subtract 5 from each side. Now, this time, because I do not have a 1 in front of the x squared, I have to add a step where I factor out whatever number is in front of the x squared term. But again, I'm going to add something to the left-hand side and something to the right-hand side. So I have a perfect square term. And this time I'm going to have a minus sign that comes down since my second term was negative. Divide that b by 2 gives me a 2. 2 squared is 4, but this time I'm going to subtract 12 since 4 times negative 3 is 12. So I've already subtracted 12 from the right-hand side. Combine like terms. Before I can take the square root of each side, I need to divide each side by negative 3, get the square root term by itself, so that we have x minus 2 quantity squared is equal to 17/3. Now I'm going to take the square root of each side, so x minus 2 is equal to plus or minus the square root of 17/3. Then I need to rationalize this radical. So that brings up to square root of 7 over square root of 3, so that means I need to multiply the top and bottom by square root of 3 to get rid of a radical in the denominator. Then add 2 to each side. And my solution is x is equal to 2 plus or minus the square root of 51 over 3. Let's review our third method of solving quadratic equations, which is using the quadratic formula. Remember what the quadratic formula is that you need to memorize is x is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's review this by looking at our first example, example number 9. For this example, notice that a is equal to 1, the term in front of the x squared, b is negative 2 in front of the x, and c is negative 6, the constant. So that means x is equal to opposite of b plus or minus my b squared minus 4 times my a times my c all over 2 times a. So now all we do is multiply. So let's figure out what negative 2 squared is, which is 4, plus 24 divided by 2. X is equal to 2 plus or minus, adding the terms underneath the radical, gives us 28 over 2. Now we need to simplify the radical as possible. Well, I know 4 times 7 equals 28. Well, 4 is a perfect square root, so square root of 27 comes to the square root of 7. I know I have GCF on top, so I can factor out the 2 from the top and the 2 from the bottom. So that leaves us 1 plus or minus the square root of 7. The 2's cancel out, and x is equal to 1 plus or minus square root of 7. We've solved number 9 using the quadratic formula. Example number 10. Here in this problem, a is 2, b is 3, c is negative 6. Again, x is equal to opposite of b plus or minus square root of my b squared minus 4 times a times c, divided by 2 times a. Multiplying the numbers underneath the square root together, I get 9 plus 48 divided by 4. Negative 3 plus or minus 9 plus 48 is 57. Square root of 57 divided by 4. Now 57 does not break down, so this is my answer. X is equal to negative 2 plus or minus square root of 57 divided by 4. The last method of solving quadratic equations we learned last year is to solve quadratic equation using technology or using our calculator. There are two main ways to do this using the graphing process of your graphing calculator. One, you rewrite the equation so it's set equals 0. Then you plug it into your graphing equation, graph it, and find your x-intercepts. Or if you have it not equal to 0, you have two methods. One, you can rearrange it so it's equal to 0, or you can put the left-hand side of the equation as y1 and right-hand side as y2, and then find your intercepts. This method, I'm going to use example 1, which is going to be 4x squared minus 4x plus 1 equals 0. And then for the second method, using the intercepts of the two equations, I'm going to use the equation x plus 3 times 2 minus x equals negative 6. And I'm going to show you the two methods using your calculator to solve these two equations. Equation equals 0, the first thing you do is go to your y equals button and insert the equation into your y1. So I'm going to put my 4x squared minus 4x plus 1. Then you graph the equations, and we have my graph key. Now we're going to find the x-intercept, this little spot here. So let me zoom in so you can see what I'm looking at. So our x-intercept is that point there where it crosses the x-axis. That's the solution to our equation graphically. So remember, to find that, we're going to go to second trace, which is our calculate button, and I'm going to move down to 0, which is number 2. Now it says left bound, so remember my cursor needs to be left of that 0, obviously to the left of the 0. Now it says right bound, so my cursor needs to be obviously to the right of that 0. Push enter, and then enter one more time, and it gives us our solution. So notice here, it gives us that 0.49999, which remember rounds to 0.5. And if you all back to one of our first examples, example number 2, we solved this equation algebraically by factoring. We found our answer was x equals 1/2. So notice the x is our answer that we're looking at. X is equal to 1/2 is our solution to this problem. Example 2, it's not set equal to 0, so this time I'm going to go to my y equals, and I'm going to put the left-hand side of the equation into y1, so that was parentheses x plus 2, close parentheses, times by 2 minus x, close parentheses. And then I had that equal to negative 6, so I'm going to put the negative 6 in my y2. So I'm going to cursor down to y2 and put negative 6. Then I'm going to graph these two equations. My left-hand side is going to be blue, my right-hand side is going to be red in my graph. And remember, when we're doing this solution, our solutions are where these two equations meet each other, when they intersect each other. So I need to find the intersection of these two graphs. So to do that, I'm going to go to my calculator button again. Remember, it's second trace. And I'm going to cursor down to intercept, which is number 5. Then I'm going to move my cursor so it's close to my first intersection I want to look at. So I can either be above it or below it. This one doesn't matter if I'm to the left or right of it. So you can go whichever direction you want. But I want it close to one intercept. It has to be closer to one than the other. So I'm close to that intercept. Push enter. And then automatically moves to the other equation and it's close to it. So it's already there. I don't have to do anything. I just push enter 2 more times. And they give me my first intercept. My x is my intercept that I'm looking at. It's only the x. So my x equals negative 4 is my solution, one of my solutions. Second intercept, we repeat the process by going to calculate. So second trace. And I'm going to cursor down to number 5, which is the intercept button. Enter. I need to move my cursor closer to the second intercept. Enter. Now again, it doesn't matter if I'm below or above. And then I need my y-intercept close to it. But remember, I need to be close to it, but it cannot be on the intercept. My x answer is my second intercept. So my second solution is 3. And that is the two different ways you can use your calculator to find the solutions to different quadratic equations.